All right, today we will be filling in our notes about direct variation, and we started some of these notes in class. If you will go ahead and pause the video long enough to go ahead and copy the tables that you see on this page in your journal. This is going to be on page 44 for the 7th grade advanced math students, and we're trying to answer the question, does it show direct variation? All right, table 1 is already completed here for you, and you can see that the first thing we did was we found out if this was representing a linear situation, and to do so you can find the slope. You can find the slope by finding the change in y over the change in x, which is 5 over 1, and that's a constant rate of change throughout the table, so this is indeed linear. And then the second thing we checked for was whether or not this represents direct variation. You can tell that it represents direct variation because it goes through 0, 0, which is the origin. And we also say that this is proportional because direct variation will go through the origin. There will be a proportional relationship shown here. Okay, then in the second table here, we can do the same thing. We cannot see 0, 0 in the original table that was given to you here in green. And so what we went ahead and did is we counted the slope by doing the rise over the run. Negative 16 over negative 4 is consistent throughout the table. And then we looked to see if 0, 0 would be in this table. So the appropriate placement here, a 0 would fall right in between negative 2 and positive 2. And then if you come over here, since 0 is exactly halfway between negative 2 and positive 2, we can go halfway between negative 8 and positive 8, which will also be at 0. And so you then can see that the table does show 0, 0 as part of this graph. So it is also direct variation, and it is proportional. Okay, now we're looking at the third table. Excuse me. In our third table, we can look, and obviously we can tell right off the bat that this line is going to go through 0, 4, so it's not going to be direct variation. But we're going to go ahead and check and see if it is linear, if it is going to make a line. And so we will check that by doing our slope. We will find our change in y over our change in x. And from 4 to 8 and 8 to 12, 12 to 16, you can see we're consistently going up by 4. And for our change in x, we are going up by 2. So our slope is going to be up 4 and over 2, and that is consistent throughout the table, so this is definitely linear. So we can go ahead and write that we have a linear situation. However, this time it is not direct variation, and that also means it is non-proportional. So we're going to abbreviate right here, not direct variation. It's also non-proportional. Okay, if you were to graph these points, they would be in a line, but they would not be on a line that goes through the origin. Okay, now we're going to move down here to the fourth table. And we have an x and we have a y, and again we're going to begin by deciding whether or not it's linear, because if it's not linear, it's obviously not going to be direct variation. So we're going to go ahead and find our change in y. We are rising up 3. And we're going to put that over our change in x, which is dropping 4. We're going down 4. And our slope is consistently 3 over negative 4 when you put the y over the x. So this relationship is linear. And now we need to decide whether or not this relationship is direct variation. Now we cannot see 0, 0 right here on our table, and it doesn't fall very nicely between any two of our points like it did up here when we were able to find that 0, 0 would be in the middle of these sets of points. Since our x values are down here in the negatives fairly low, we could work our way back and see what happens at negative 10 and negative 8 and negative 6 and negative 4 and negative 2 and then up to 0, and then work our y table back in the same manner by going down 3 for each of these and see if it goes through the origin. But there's another way you could do this, and that's what we're going to do on this problem. So if you want to know if it's proportional and you do not see 0, 0 in the table, then you can just look at the relationship between the y and the x value that you have here. And so if we were to look at that relationship, if we put the y value over its corresponding x value, so 6 over negative 12, And then the next y value over its corresponding x value, we have 9 over negative 16. And then we have 12 over negative 20. And then we have 15 over negative 24. Okay, and then we're going to take a look at those numbers that we have. If you were to take those fractions and you were to simplify them, you'll see that there's not the same relationship between 6 and negative 12 that there is between 9 and negative 16. If you were to simplify 6 over negative 12, it makes negative 1/2. 9 over 16 does not simplify anymore. 12 over 20, you can divide both of those by 4 and you'll get 3/5, so that's negative 3/5. And then 15 and 24 can both divide by 3, and you get negative 5 over 8. And obviously these fractions all simplify to something different. And so that right there is our clue that this is not direct variation. So although this is a linear relationship, it is not going to be direct variation, which means it's not going to go through the origin. So we're going to go ahead and write that it's not direct variation, which also means that this is a non-proportional situation. Now we're going to take a peek back at number 3 here just to see that you could have done the same thing here. If you were to place 8 over 2 as a fraction, that simplifies to 4 over 1. 12 over 4 will simplify to 3 over 1. 16 over 6 would simplify to 8 over 3. And then 20 over 8, let's see, that would divide by 4 and it would simplify to 5 over 2. So again, these will not make the same fraction whenever you compare the y with the x using those coordinate pairs. So that's another hint that that one is non-proportional as well. And you'll notice if you look back at the proportional relationships that they do simplify to the same fraction. 24 over 6 just simplifies to 4, 8 over 2 simplifies to 4. All of these simplify to 4 because it is proportional. But if it does not simplify to the same fractions, it is a non-proportional relationship. Okay, let's take a look now at the 5th table. Alright, and so we're going to look right here, and the first thing we're going to do is we're going to find our change in y over our change in x to see if it's linear. And we notice here that it is decreasing by 7, and then decreasing by 5, and then by 3, and then by 1, which is a little bit different than what we've seen before. And then we notice over here, let me switch colors here, that the change in x is going down by 1. And we notice here that our rate of change is not consistent, it's not constant. So we have negative 7 over 1, and then negative 5 over 1, and then negative 3 over 1, and then negative 1 over negative 1. And so when you look at those, that these are not the same rate of change throughout the entire table. So we realize then that this is not even a linear relationship. This is what we would call non-linear. And obviously if it's non-linear, if it doesn't make a straight line, it's automatically going to be non-proportional, and it is not going to represent direct variation. Go ahead and divide that up a little bit here. Okay, and then we have one more situation right over here that we're going to take a look at. Now this one looks a little different because it looks like our table goes down and then back up. It's kind of moving around here, but that's okay. We're going to take a look at it. We can see here that our rate of change is going to be dropping 2, and then we notice right here it goes up 6, and then up 2. So again, that's a little different than what we've seen before, but let's continue checking our change in x and see what happens. So whenever you find this change, it drops 50, then it drops 50 again, then it goes up 150, and then up 50. And so we have a little bit of difference here, but what we'll still do is go ahead and take a look at how our y's compare to our x's. And if we take negative 2 and we put it over negative 50, that slope will simplify to 1 over 25. Well, the same thing happens here when we put this negative 2 over the negative 50, and it simplifies again to 1 over 25. And then if you put 6 over the positive 150, that will simplify to 1 over 25. And again, we see that positive 2 over 50 simplifies to 1 over 25. So actually our rate of change is constant here. So this is definitely a linear relationship. And now we need to decide if it's direct variation, which means we need to find out if it's going to go through the origin. And so since we do not see 0 on this graph, we don't see what happens whenever the x value is 0, because that would tell us whether or not it crosses through the y-axis when the x value is 0. We're going to do like we did over here in the fourth one, and we're going to look at this relationship between the x and the y values here. And so I'm going to put my y over my x, and I'm going to put 6 over 150. And then I'm going to put 4 over 100. And then I'm going to put 2 over 50. And then 8 over 200. And then 10 over 250. And I'm going to simplify all these fractions to see if they simplify to the same thing. So 4 over 100 is pretty easy right there. That's going to be 1 over 25. 2 over 50 is also pretty simple. These take a little bit more work, but when you divide these as well, by 6 you can divide 6 by 6, you get 1. 150 divided by 6 will make 25. 8 and 200 will also simplify because 8 goes into 225 times, and so that will make 1 over 25. And then 10 over 250 makes 1 over 25. So when you see that these fractions simplify again to the same relationship, you can see that these proportions, if you compare any two of these numbers, like 6 over 150 to 4 over 100, that these are truly equal to each other. They have the same value, which is why we say this is a proportional relationship. And if it's proportional, it's also going to be direct variation. So let's go ahead and write those words. Okay, so that's just a little bit of practice with using tables and working with direct variation. So if you'll be sure that that's copied into your notes, and have a nice afternoon.